Okay, in this video, we're going to learn how to use the Pauling scale here to determine whether or not a covalent bond is polar covalent or non-polar covalent. You can also use the scale to determine whether or not something might be ionic, but we'll get to that a little bit later. So first, I would make sure that you have an image of this in front of you. Either take a screenshot of it from your previous slide or have it on your phone, because this is going to be very useful to us. As a reminder, the bond continuum range are listed as such. A difference in electronegativity between 0 and 0.49 will result in typically that bond being non-polar covalent, so they will share the electrons equally. A bond continuum range or electronegativity difference between 0.5 and 1.69 will generally result in a polar covalent bond. In such a case, they will not share the electrons equally, and the atom with the highest electron or highest electronegativity will pull on those electrons harder and have the partial negative charge. If the bond or the electronegativity difference is 1.7 or greater, then you're in the ionic range, and we'll talk more about ionic bonds a little bit later. So let's go ahead and go over a few examples right here. Determine whether the bonds formed will be polar or non-polar covalent. We have a bond between carbon and fluorine, nitrogen and oxygen, carbon and hydrogen, and then hydrogen and bromine. So let's start with this first one. The two atoms in question here are carbon and fluorine. Let's go back to our bond continuum and find carbon and fluorine. Fluorine has an electron or Pauling scale rating of 4.0, and then carbon has a Pauling scale rating of 2.5. If we come back over here to our example, we will take 4.0, which is the bigger number, subtract it from the smaller number, and that'll come out to be a difference of 1.5. Okay, and the range of 1.5 lies in the polar covalent bond range. So a bond between carbon and fluorine will be a polar covalent bond. Alright, let's do nitrogen and oxygen next. Nitrogen is right here and oxygen is right here. The Pauling scale rating for oxygen is 3.5 and for nitrogen it's 3.0. So we'll do 3.5 minus 3.0, and that's going to be equal to 0.5 on the dot. In such a case, it is a polar covalent bond, but just barely. Alright, now let's do carbon and hydrogen. Carbon is right here at 2.5, hydrogen is up here at 2.1. So we will do 2.5 minus 2.1, come out of a total of 0.4. 0.4 is in the range of a non-polar covalent molecule, so we will write non-polar covalent. They will share the electrons equally. And now let's look at hydrogen and bromine. Hydrogen is right over here again still, and then bromine is right here. 2.8 minus 2.1. 2.8 minus 2.1. It's going to be 0.7 on the Pauling scale. And so we are in the range of polar covalent for this one. And that's pretty much all there is to it. When you don't have a Lewis structure and cannot easily determine the polarity from a Lewis structure, then you'll have to use the Pauling scales and differences in electronegativity. This is a good time for me to remind you that this is very much just a set of guidelines, okay? This is not a foolproof method of figuring out whether or not a molecule or compound is polar covalent or non-polar covalent. Again, it's just a set of guidelines. There are cases in which nitrogen can bond to oxygen and still end up being a non-polar molecule. Okay. Same thing with carbon and fluorine. There are instances in which carbon and fluorine can bond but still end up non-polar covalent, but we will go a little bit more deep into that when we get to topic 2.5. In the meantime, try the example problems and we'll see you in the next video.